Ainesh, please unmute. Right. Daniel, I can see you, yeah. Let me just talk to the rest for a while. Ainesh, please unmute. In the meantime, Daniel, please set up the Zoom video thing.
Hello?
Yes, Ainesh. Okay, I can hear you. Yeah. All right. So I will have you discuss the
Hello.
two homeworks. Yes, Ainesh, can you hear me?
Hello. 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 I can hear you.
Can you hear me? Are you sure?
Yeah, I can hear you.
Okay, good, good. I thought there was a problem. Okay. So asking you to discuss your homework with Kakak Brian first. The two homeworks. That means the lock in these three goals, and then the polynomial that you tried today. Okay.
What about the science?
Oh, the science will come. You discuss first, and then you prepare for tomorrow's homework.
Okay.
Right? Same thing lah. Same thing. After that, then we talk about science.
Okay.
Okay. Okay. Right. So I'll have you with Kakak Brian in the breakout room. Yeah. Right. So again, Daniel, can you hear me?
Yeah, I can.
All right. Okay. So while you're setting up the video, I explain a little bit here. You notice that it's a holiday class, not a normal class. Normal class are usually more of the same type of student. In holiday, either some students take a break or some other students do more. You belong to the students who do more, right? Okay. So in general, for today, at least for this week, I think you need to ignore the other people first, because they are not doing the same thing, and they are in the different stages, right? For example, your senior here, Yankin, is simply preparing for his A level, right? So I'm asking him to be here. I'm here for him just for moral support. There isn't much discussion going on, for example. Okay. So
Okay, sure.
don't mind the other people for now. We're not going to interact too much because again, this is not the normal class yeah. Okay, so having said all that, we're gonna start with the video and then if there is no violent objection, we're gonna talk about the field.
Okay, just give me a minute.
Sure.
Setting everything up.
Yatkir, how's things with APGP so far?
I did get one part, but a lot of it was algebra and like guessing. I don't know how else to put it. It's pure algebra.
It is.
But now I'm moving on to SN and it's just a bit difficult to
Okay.
wrap around.
Yeah. You do have to check the answer key every time afterwards.
Yeah, I can do.
You do have to not just look at it, you have to repeat it so that it gets in. If not, then no point. Right. So yeah. Other than that, the troubles are expected, but you seem to want this topic, so go for it.
Right.
But if there's anything I can do to accelerate, you ask, video and everything, right?
Yeah.
Right. Okay. I can see your video, Daniel. Good. It's pointing upward, so easy to fix. Yeah, got it. Okay, right. So your physical notes would be great. Taking picture with the Jamboard from the tablet will probably also be helpful. Now I should be accessing your Jamboard also. So let's see whether no. Oh. Hmm. Sorry, wait. All right, okay. Your lecture note on field.
You can
Yeah,
get
thanks.
my video and me back to the room.
Sure thing, I know. Let me do that. Assign. Yeah. Okay. The first one you join yourself. I can no longer assign because it is already assigned. The new thing, the new guy, I can. Okay.
Oh, okay.
Right. Sorry about that. I think I assigned the wrong guy. Actually, wait. Assign to room one. Yeah. Done. Actually. Okay. All right. Good. Okay. So, no objections. We're gonna start with the field first. Daniel.
Yeah, no worries.
Right. Okay. So, would you in our situation, muting is counterproductive for now. We'll be talking a lot. So I think it's easier to just yeah.
Me too.
Now, help me see your lecture note very quickly. I just want to know what's inside lah, and maybe there's some pressure we can use. All right. Okay. The distance seems nice. Good. Okay. Flip, please. Flip. Flip to the next page. Okay, not gonna worry about this. Then flip again. Not gonna worry. Okay, flip again. Okay, finally we're seeing something here. All right. Okay, then flip again. There is some curve. Okay, good. There's some curve going on. So flip again. Where's the combined curve? Don't have. All right, flip again. Okay. Okay, right. Okay, I'll move again. I'll flip again. So somehow he shifts to G field, right? Okay, I'll flip again. Oh. Flip again. Okay, right, flip again. Okay, that's normal. I guess you will go there now. Okay, flip again. We're almost at the end, right? Oh, there. right? Okay, then please continue. Yeah, okay, sure. Okay, then. Okay, we have some questions here. Okay, good. Right, good. And then this, let me see what this is. Okay, sure. Okay, could you enlarge page 58, 59 for me? Let me see the summary.
Yeah, move it down. The work.
If I can't, okay, then let's take a picture. Picture using Jamboard. Let me see them.
Oh yeah.
Right, just 59, yeah.
Yep.
Okay, in Jamboard, you can move the pages around. So what I'm going to do is I'm going to move first page to next to or before the page that you took a picture of, right? So then your things are better way of doing it. Right. So I'm going to enlarge it, yeah. So we don't double work. Oh, it's very small. For important page, that's so small, isn't it? This is what it is then. All right, okay. So after uniform field, what? Okay, next page.
Last picture.
Okay, understand. Right. Okay, so here's probably how it would feel, Daniel. It will feel abstract, so many things just for a while, yeah, just for a while. Then it will make sense when we start to look at the questions. That means the question is our guiding goal. Without that, this topic is a total jumble of mess. We don't even know what to think, right? But at the start, you have to bear with me. Just so happens you start this tuition in the some people. Maybe this is the hardest topic. Maybe. Yeah. So maybe that's good, right? Maybe that's good, right? Maybe that's where you may benefit the most, but bear with it for a while, right? Okay. Back then when you were doing year 4 and year 8 and year 9, do you have that separation between math and advanced math, something like that?
Yeah.
Okay. Do you call that the E math or the C math, something like that, and A math?
Yeah, C math.
Okay, C math. Sorry. So if I'm not mistaken, this is in your C math lah. So you will learn the shape of this graph, this and this. They are slightly different lah. Right. So I'm referring to a Jamboard. Yeah? So if you could place your if you just look at your Jamboard, that's fine. You can look at it in your laptop. You can look at it in the tablet, right? Right. If you're looking at a tablet, yeah. So you put it there. Right? So they may ask you to recognize the shape of these two things from your CMAT law. Did you remember anything like that?
What's the top of the X there?
Oh, there's an X square. Okay. So do you remember something like that?
Y is one over X and Y is one over X squared.
The shape of those two graphs.
Oh, the shape of those graphs.
Yeah, the shape.
I remember them teaching it, but I don't remember what it looks like. I think it will look like. Yeah.
You can draw in the Jamboard, easier, right?
Let me think.
Yeah. So make a guess.
So like that.
Okay, sure. Okay, right.
As Y increases, X will decrease.
So how does it look roughly? Right?
Yeah. Or like as X increases, Y decreases.
Correct. So how does that look like? Okay, no, that's
above.
Yeah.
Yeah,
I think we get a general shape, but the shape is more like okay, because if it is what you said, right? If it's what you said, then I guess you're not wrong lah. It is true that that's increasing, decreasing lah, right? Okay. Bearing in mind that closer to 0, this will be infinity lah, something like that. Okay. Bearing in mind.
Okay.
So when x is equal to 0, y approaches infinity lah, okay? Right. With that in mind, I will put it more like this lah. Okay.
Okay.
Right. Okay, this will be very important, right? Because what you describe as, you know, as x decreases, y increases, that's exactly what's happening in both the electric force and electric gravity force. So if you go closer to something, it will attract you or repel you harder. That's decreasing the distance, increasing the force, right? And yeah, right. So this one belongs to that, something like that, okay? Then the other one will look very similar, like that. Okay. And yeah. Now, I will use this picture in your mind, right? These two things, you should have it in your mind. And I would like to link that to the formula so that the formula which is scattered will be gathered nicely, right? This is an effort to simplify the memorization of the formula, right? Okay, that's the effort. Without that, I think it's too scattered and it becomes very confusing when you try to apply it, right? So look at the formula of the force first, right? Force is something that you know. We're not going to talk about field. So
It's
force.
so small. Wait, what?
I'm sorry.
Yeah, man. It's really small.
It's really small. Yeah, I don't know why such an important summary is so small. Right? I'll make it bigger. Right. So a constant can be assumed to be another constant. Can be assumed to be another constant. Correct or not?
Yeah.
There you go. Look at that. Look at this guy and tell me this guy will look like which one?
Gravitational potential energy.
Which one?
Oh, wait, looking at this one. Oh, second one.
Good. Second one. Right. Second one. Right. I'm gonna do the G field, remember? So now small g is no longer constant, right? So G field is here. G field is there. So a constant, another constant, right? There you go. Right.
So which one is this?
That's a small g. Small g refers to what you call the gravitational field. Right? Do you have it? Do you have it in your summary? Well, yes. Look at that. This guy. Okay. Notice that I separate the variable from the constant. They don't behave differently. They don't behave the same. Big G and big M behaves like a constant because they usually are, right? Sorry, G is a constant. Big M is usually a constant, right? But R is usually not, right?
This is
So
the 10.2.
10.2. What do you mean by 10.2? Sorry.
And we'll see which chapter is this.
10.2.
Yeah, it is.
Okay. All right. Sure. All right. Something like that. But my point is clear. Yeah? My point is that the 1 over r squared is the variable. This is the variable. This is the constant. So I want you to see it that way. Okay. The last thing I want you to see is the relationship between them. The relationship between them is very easy. The relationship between them is times m or divide m, which is, mind you, another constant, right?
M is the second mass.
Yes, which is, if it is us or if it's satellite, it can be moon, we usually just assume that mass to be constant.
Okay, so just
now,
this one is field, this one G field, and this one is G force.
G field is no longer constant in situations that we're going to look at. Right.
So what is this again?
That's the force of gravity. Sorry, that's a very bad writing. So I just write down as FG, force of gravity. which you usually know as weight, which you know weight as constant. Why? Yeah? Because you thought small g is constant. So weight is constant. Now, no longer. Look. Now, no longer. Right? I didn't explain much about this formula, how they use it, no, but I'm getting you familiar to, first thing first, the shape, the expected shape. Secondly, the relationship between them. There is a minus in these both two guys, which I'm going to conveniently ignore for now. Okay, I'm going to conveniently ignore them for now. They will mean something soon enough, right? Okay. Okay, so one more time, what's the relationship between the small g and the fg?
And they're connected by like M.
Another mass, right? Another mass. Yeah. Now you see why I say small g is almost force. You just need another mass appear and two masses will now interact with each other, attract each other using gravity force. Now, I'm going to compare them directly with the Fe. Fe is, of course, the electrostatic force, right? Okay, and then this is the E field, the strength of the E field. Now, guess what? They are really, really very similar, right? Okay, I'm writing something that doesn't appear with. Sorry, wait. Okay, I'm just restarting. Okay, good. Okay, Q1, Q2, 1 over R squared. Well, isn't that convenient and very similar, right?
Sorry.
Yeah, look at the gem word. Electric force or electrostatic force, right? Okay, so constant, charge, not mass, but constant, charge, not mass, but constant, and then the distance, which is not. There you go. Okay.
So they differ in
No, they don't differ.
Wait, that's a square. Okay, sorry.
Yeah, R square. They don't differ at all. Their structure is very surprisingly the same, considering that they are very different things. Their structure is surprisingly the same. You need two charges for, electrostatic force to appear. Okay, yeah. So guess what the E field will look like? You're gonna write down.
The E field.
Yeah.
Is
gonna be, yep, and that's gonna
be yeah.
I know that's the shape, but I'm asking you for the formula. The formula becomes the shape. The shape is the formula. They are the same thing. So what's the formula?
Q1 over R squared.
Yep, that's it. That's right. So in terms of memorizing, it's not difficult to memorize at all, right? Okay.
The E is a big E, right?
Big E in this case, yes, not small. Yes. Now, whenever they give you the shape of the graph, it implies the formula. There is no other thing. The shape, the graph that they give you will come for the formula. They are just conveniently sketching it for you. Okay. There is no other graph that comes from another formula. This is the formula, right? Okay. There will be complications, but it will come back to this formula. That means the graph is the formula is the graph, no other thing. The graph that you're seeing in front of you, for example, this is a potential graph, right? Versus R. I haven't drawn the V graph yet. The V will have a formula. The formula will become the graph. The graph is from the formula. Yeah, you understand me? Yeah, right. So there is no other thing. The graph is just the formula is just the graph. Now, for reasons that you will see later, the graph they give is only the field. They never give you well, cannot say never lah, but let's just say that they almost never give you the force graph, they just give you the field graph.
Uh,
But they will ask you for the force, and that's not a problem, right? Because force comes from field very easily. It is really very easily done, right? They'll just give you the graph field, okay? The field or the graph field.
okay. Hmm. Okay.
All this shouldn't feel overwhelming for now. It is not supposed to be, right?
Wait,
Okay.
just to confirm, these two have the same graph.
They have same looking graph.
Ah,
Same looking graph. Why? Because the only thing that affects the shape of the graph is this. The rest are constants, man.
yeah, but how do you plot? Like, what's the scale? I say, what are the
Yeah.
axes for these kind of graphs? What's the x? What's the y?
The x is the r, the y is the small g or big E, just like your CMath. Just like your CMath, nothing else.
Okay.
Right? I'll put it another way. It's not that CMath is easy. That's not my point. My point is, if you forget the shape, it's like you're forgetting CMath, which means you just have to reclaim that back. Right? There is no other fancy math going on so far. There isn't. Right?
That's true.
Yeah. Right. So moving forward a little bit more. I'm going to now put two more formula because there is only two other basic formula, right? So the field chapter, the title is a bit misleading. It's a package of four brothers. So you have two of the brothers here already. These two brothers are particularly close to each other, right? The force and the field. That's why I call field almost force. Now let me present to you the other two brothers. Sorry, my Gmboard is not published. Okay. Right, so I'm going to put potential here. That's the third brother. And I'm going to put work here. That's the right. Okay, what I want you to focus on is the fact that the formula is very simple, even though you don't understand.
V is potential.
Potential, in this case, I'll call it potential gravity, and then there's a potential electric. It's a very weird concept. I am not teaching you what that means. I'm just showing you the formula. The formula is exceedingly simple. Look at that. The work done by gravity and work done by electric. Whatever that means, the formula is exceedingly simple. Okay, look at that. Okay, so what does that remind us of? Reminds us of CMath again. CMath, W is work.
Okay.
Work, potential energy, whichever that is joule, right? So whatever it's here, for now it's there. My point is, it is back to your CMath again. No?
Okay.
Right? It's back to your CMath again. No? This guy for these two. Okay.
Okay.
So would you kindly guess what is the work done by electric field? And then go back to Gmboard. Yeah. Work done by electric field, and then work done by the potential of the electric field. So would you kindly guess the formula?
Okay. KQ 1 over R.
Which one?
Uh,
You can try writing with the pen, right? That'll be okay.
it's a bit hard to write because it's not really on there.
It is.
Let's try.
It is. But just give it a try for now.
Let's see.
Yankin, just checking you're okay. Yeah?
Yeah, I'm fine.
Right, good. Right, something like that. Yeah.
Uh-oh.
Yeah, you can undo lah. I mean, you accidentally delete something, so you can just undo that.
Wait, what did I delete?
I think you delete somehow
I deleted
accidentally
a picture.
Yeah, which is fine. Just undo a bit more, undo a bit more. Yeah, that's fine. That's fine. No, yeah, okay, there you go. See, it's fine. And then the work is like that. Yeah, you are a left-hander.
Yep.
Oh, that thing is going to give you more trouble. Okay.
Yeah.
Right. Okay. So 1 over R. Right. So we are back to CMath. We are back to that thing, something that you have learned before. Right. The rest are constant. There's only 1 over R. So far, so good.
Mhm.
These two other brothers is less familiar than the first one, but their relationship is very important. Look at their relationship between potential and work. So easy, right?
It's the same
Correct.
as between field and force.
Right. And voila, what graph will they give you? The potential graph. They will never give you the work graph. Right. Right. Let me that one. Right. If they ever give you a graph, it will be of that shape and form. And then, well, they're gonna ask you work, but they're gonna give you the potential graph. They're gonna ask you for force, but they're gonna give you the field graph, for example. Again, because the relationship is very close. Right? Please notice that you are more familiar with the force concept and the energy or work concept than you are with the field and the potential concept. And yet that's what we're gonna give you in the question. All right. So far, so good. Yeah. Now, the final thing, okay? The final thing is the relationship. So there are two more relationships, right? This relationship and that relationship. Okay, that relationship. One of them is integration and one of them is differentiation. All right, so I'll go to the differentiation route. Okay. Right, so differentiation integration is your AMAT law. If your AMAT in year 10 so I'm now referring to that differentiation, a very simple one. Instead of dy dx, I'm gonna say dw dr. Does that make sense? This is not supposed to be memorized.
Wait, so can I just cut in? What is Q stand for again? In the
charge. Charge.
Sure.
Charge as in electric charge, coulomb, something like that. Right. This is the first time you hear about Q? Sorry.
So I just need to jog my memory.
All right, no problem. Right. So I hope this is making some sort of sense that the gravitational force will involve mass, but the electric force will involve charge, electric charge. Right. That's how it works.
dw is
dw, d work, dr. Now, does that make sense? This is your
integration or differentiation?
That's differentiation. I'm differentiating w with respect to r. Does that make sense? It's just y and x, so dy dx, dw dr, because I mean that's the only two variable, right? That's all I'm doing right now. Why am I doing this? Because the relationship. That's why I'm doing this, because keeping it simple, the differentiation of work will become your force law. Right. So I'm going to ask you to try this in terms of math. Okay? You're going to differentiate. You're going to differentiate this and see what it becomes. And I'm not talking about physics, I'm talking about math. So please do so.
Okay.
Right? Your year 10 differentiation, right?
Differentiate this and this.
Yeah, differentiate that. Yep.
Mm,
Now, if you could help me shift your handphone to the left, then I can see your writing better. Right? Is it possible to do that? That means shift the whole thing to the, not the Jamboard, but your whole stand to the, or you can do that also. Right? Okay. Right. Now, please note for your differentiation, it will be better, math, yeah, that your 1 over r is r to the power of -1. Now, if you still need me to jog your memory, I will ask you to do y equals to x to the power of -1. Now, all right.
I got
Great.
it. All
So,
right. So differentiate this.
differentiate. Okay, differentiate that, which is r to the power of -1. That's the easier way to, yeah. So what do you get if you differentiate this? dy dx means dw dr, right? Yeah, good. Now this will become correct. And then all the constants, the g, m, m will just stay there, right?
We differentiate on the constants. Those are numbers.
Yeah,
Sorry.
the constant stays, it's just a number. So g, m, m, that's it. It is a very simple differentiation because it is a simple differentiation. Now, my point is, it's better than that. My point is, isn't it correct when you differentiate the W, you get force? Right, with the minus sign, mind you, the minus sign is there, the minus sign is there. Okay.
The minus sign is,
The minus sign is there. So I was telling you just now that the F has minus, so I don't explain much, but there you go, there's the minus.
So the formula, where you see my writing, this formula should have a minus.
It is. And the minus has a meaning, right? Which we haven't discussed right now. So I'll just say that it is there, right?
This one also.
Doesn't. The electric
it's
one
just G.
It's just G.
Oh,
okay. Right. But back to the focus, isn't what I say correct? Differentiation of work gives you force. Right?
What?
So when we learn from year 10 math, integration of force becomes work. Right?
Okay.
Right. So would you kindly write that down in terms of math? Integrate FDR becomes W. Right? That's just the other math, which you also learn. Right? Right? You write it down. Integrate FDR equals to W, or W equals to integrate FDR.
Sorry, my dad came in. My train of thought is a bit.
Mm-hmm.
So for here, differentiate. It means you differentiate WG is
becomes a
WG is what again?
Work done by gravity. Whatever that means is work for now. Whatever that means.
Oh, I'm stupid. Okay, wait. This is all gravity. This is
yeah. That's all electric gravity. I'm just comparing them, not to confuse that, but to say that they are very similar.
Wait, yeah, I messed up. I bet I wasn't thinking straight when I wrote it.
Yankin, okay so far?
Yeah, I think so. I'm just I'm looking through it.
Okay, so you differentiate the G.
Not by G, not by G, by R. dw dr, right?
Yeah, you get force.
You get the force.
Okay.
So integrate f dr, you become W lah. Correct or not?
Okay.
Right, this
Integration
is
I
still
have forgotten.
and you have not done integration in your HLNet for a
No,
while.
I have not done it for a year already.
Goodness me, Lord.
Yeah.
Okay, the good news is the integration in physics has always been the simple, super simple one. So there's nothing to jogging your memory, very simple. So first I'll write the formal writing first, integrating f dr equals to W. This is similar to integrating y dx equals to whatever it is, right? Whatever, big Y in this case. Okay, so I'm going to jog your memory on integration, right? So
You start new page? Oh,
no.
Okay.
Integrate r minus 2 dr. What does this become? Any idea?
-3.
Minus
Minus
3 means
1.
you're differentiating. Right? Good.
Yeah,
Good.
minus
First of all,
1.
it's minus 1. First of all, it's minus 1. And then you will have your 1 over minus 1 also there. Right?
Oh.
You're going to remember better when your math start doing this kind of thing. My point is r minus 1. That's all. That's all. That's all the math I'm trying to emphasize right now. So
then the
you
D
look
and
at
the R disappear.
Yes, the dr disappear when you integrate. Yeah. The point is when you differentiate, minus 1 become minus 2, the power. And when you integrate, minus 2 become minus 1. Right. Now, what you should have realized is more like this. If it is true that if I differentiate W, I have F, then it is if I integrate F, I have W, because that's just the reverse relationship of differentiation. That is what I'm aiming for here. Okay? Yeah. The math not okay. You have to tell me if the math is not okay. This is all differentiation, and finally there's some integration, right? When you're learning integration in year 10, does your teacher say something like this? Integration is just the reverse of differentiation. Did he say something like that?
Plus 1.
That should be the first and the last impression he make. Integration, that's just reverse differentiation. That's all. That is really all.
So
there isn't much to it.
R becomes like n minus 1.
Yeah. R minus 2 becomes I minus 1 because that's the reverse differentiation.
Minus.
Right. Not sure what you're doing there. Suddenly R power minus 2 becomes minus, you mean minus 2 plus 1. You mean minus 2 plus 1.
Oh, it is plus 1.
Yes. Because why? Reverse differentiation.
Oops. Plus 1. And on the bottom will be
one that is over whatever the result is, whatever the result, which in this case minus 1.
Minus 1.
Yeah.
So minus 1.
Yeah. Right. That's integration, the reverse of differentiation.
Okay.
Okay. Now, this relationship between W and F is new, even though you learn force and work before this. The relationship will seem new, and this is highly emphasized in this topic. Highly emphasized.
In
The
WML.
relationship, the differentiation relationship, and the integration relationship is highly emphasized.
So it's likewise if you integrate force, you get work done.
Correct. Correct.
You get W, you get R. Or you just get work done.
Both are function of R. So if you integrate force, which is a function of R, FR, you get W, which is a function of R, WR.
Okay.
Something like that. Okay. So in math, I'm just clearing up some loose ends here. In math, you learn double differentiation. You can differentiate and then differentiate again, right?
Yeah.
So you differentiate work once, you become force, no? Do you gain anything from differentiating force? Because mathematically you cannot, right?
I mean, you can, but what do you gain from that?
Yeah, physics-wise, we stop short of doing that, even though we can. We stop. Likewise, integrating, so if I integrate force, I'll get work. What happens with I integrate work? Will it give you something mathematically? Sure, but what's that physically? Don't know, so we stop short.
Okay, that makes sense.
Okay. Now, the relationship, you shouldn't mix up between differentiation and integration. If you cannot, you still end up mixing up, you better memorize it, because the relationship is going to be important.
Okay.
Right? Whether hook or crook, whatever, you memorize it properly, which one you differentiate, which one you integrate. Okay? Now, look at the other two guys. Look at the field and the potential. Those two are the weird guys, right? The weird guys. Don't know who they are. They are new. What's the relationship between them?
Differentiation, integration.
Yeah. Who differentiate become who? Who integrate become who?
You integrate field, then
it becomes potential. You differentiate.
You differentiate potential, it becomes field.
Yes. The same exact relationship with force and work. The exact same.
P is potential. This one is
okay. And yeah, this is not overwhelming yet.
Yeah, sorry.
All right. It doesn't mean much yet though, but it is not overwhelming. That's already good. Now, the final explanation before we can try to apply them, right? Back to the graph, okay? You know that graph-wise, differentiation means the gradient, right?
Mm-hmm.
And then integration, graph-wise, that's the area under the curve. That's what you learn in year 10. So the graph of W, if they ever give you the graph W, I tell you that they never, right? They give you the graph of potential, right? But if they ever give you the graph of W, the gradient of W is F low. Math still applies here, right? If they ever give you the
W a curve.
It is correct.
So
that's why
the
a curve
average
have
gradient.
No. The gradient at that
gradient
point.
At a given point.
At that point, yes, and that's very important.
Whichever point the question asks for.
Yes, because the force changes, the gradient changes. Voila, the force is variable, so the gradient is variable. That makes sense.
To find it, you have to like draw attention at the point and then find
usually yes, that happens in physics some of the time. Yeah. Math happens in physics, right?
Yeah.
Right.
Okay.
if I never put this at the start, you will encounter this at the end anyway, right? When your teacher start to jump into question, then you have an impression that all these are super new stuff lah. It's not. It was from your math,
Okay.
right? So you will not be surprised when this happens later on lah. Oh, okay, told you before. Okay. So one more time, the gradient of the work graph is force law. The area under the force graph is workload. One more time, integration, right? Integration of force becomes work, correct?
Yeah.
So the area under the force graph is workload because that's what it means graph-wise for integration, area under the graph.
What word two?
I'm sorry, you say?
What did you say?
The area under the force graph
Yes.
is
You
work.
said word two.
Is work.
Work. Oh.
Work, W.
Okay.
Because graphically, that's what integration means, area under the graph. Okay.
So it gradient and
The gradient of the work graph.
it will be gradient and area under.
They're not the same graph. When I differentiate the work. Because differentiating F can or not? Can, but it is nowhere. Can.
So if you're given a work graph, you differentiate it to find
If F,
which will be
because
the gradient.
yeah, the gradient of the work graph lah. And if they give you the work graph, they will not give you the force graph. Confirm one. They don't nice give you both one. No, not gonna happen.
Okay.
If they give you the force graph, they're not gonna give you the work graph. But if they give you the force graph, they're gonna ask you for it. They never make things easy, right?
Mhm.
They don't give you the force graph and simply ask you for force. Okay, that's easy. Just read the graph. They're going to ask you for work also. Where's the work? The area under the graph. Math law, math lah. Math is in effect here lah, so to speak. So they'll keep doing this to you lah. They'll give you one thing, they ask you for another thing. They'll give you this, they ask you for that. They give you that, they ask you for this. That's why the relationship is important lah. Yeah. The relationship happens on the field and potential side, right? Side of things, right? So I'm going to test you a bit. And what I'm saying correct or not? So you think, if I differentiate the field, I will get potential. Correct or not?
No.
Very good. So what must I do? If I have field, I want to get potential. What must I do?
Integrate.
In terms of graph, what does that mean?
Area under the graph.
Yeah, area under the graph of the field graph, right, will be the potential. Okay, so now here's something with the exam field. Let's say they give you the G graph, the field graph, correct? The field graph. And they ask you for force.
Yeah.
Why? How easy or how difficult is that?
You multiply G by another
M.
mass. M.
Yeah. Whatever M is relevant to the question, right? You have to read that.
Give it negative.
Never mind that. Both have negative. Again, never mind that. Never mind for really. Never mind for because I never say clearly that. Right?
Okay.
Right. But my point is, they can give you small g and ask you for f. They can. Of course, they can.
Okay.
Can I give you small g, a graph, let's say a graph, and then they ask you for potential. Can they do that?
Yes.
And what are you supposed to do?
Integrate.
All right. Area under the graph, lah, basically. Lo.
Yeah.
So the furthest relationship, lo, can they give you small g graph and then they ask you for work? Can they do that?
Yeah, plus 2 steps.
Yeah, correct. There is no direct step. So what's the step?
First you multiply by m,
Sure.
and then you integrate.
Yeah. Or you integrate first, then you multiply by m. Also can.
Oh yeah, okay.
Right. That's the more likely approach, by the way. But I mean, you get the point now. There are 2 steps involved. One is difficult, one is easy, kind of.
Kind of.
Yeah. I mean, the multiplication one is easy, multiplication or division. The differentiation integration slightly harder. Something like that. That's all. Okay. I summarize the mathematical aspect of this chapter. Then we can start to see what they mean. Okay. Any question so far?
No.
Right. Now you look at your summary page 59, right? Which things have we covered and which things seems new? The things that we have covered, maybe you can put a small tick. That will be nice. Okay. The things that we have not covered, oh, that's up to you. That's up to you. If you don't feel like messing up your lecture note too much, then mess up the Jamboard lah. The Jamboard is where you do stuff lah, right? Okay, then you finalize things, right? Okay, so check out what is new and what has been covered and what has not been covered. Right. Yeah, you'll notice that sometimes moving the picture is difficult, right? Okay. Yeah, and that's partly because the picture is very small, right? Okay.
Zoom.
Yeah, better just zoom in and then shift it down, something like that, maybe. Yeah, we have to start from on top, right? There's some things on top now. Right, yeah, there you go. Yeah. Why don't you start there, right? Right, this is going to be a mess, but the point is, what have we covered and what have we not covered? Or maybe I'll just make a new page for you. Let me just copy this, right? Just copy this. Let me do that for you in this case. Let's go to page 7. I have the slightly bigger version there. Right. Okay, there you go. Right. What's new and what's not new?
Am I moving this thing? Oops. Let me see. Coulomb's law is kind of new. This is Newton's law is not new. This is not new. This is not new.
Yankin, okay so far?
Yeah, I'm fine.
Yeah. Anything I can help you with?
I not yet.
All right.
But I think it might come later.
All right. Take it like you have another half an hour plus to do things, and maybe you should cool down already. Yeah.
Okay.
Right.
Yeah, the electrostatic side, I think it's mostly new. Yeah.
So the tick means we covered or we haven't covered. Sorry.
Tick is stuff I'm still not very sure.
Oh, tick is not very sure. The ones that you haven't. Oh, okay, wait. So the tick is not a yes lah. The tick means that you feel that it is somewhat new, right? Okay.
Yeah.
All right. So check this out. This part we covered what? Oh yeah, something. Okay. How come your right? The way I circle is different from the way it appears, right? Okay, so that part is covered, right? This thing is done.
Yeah, but this one.
Right. So what is new there? He's just
I can't even
telling
see
you.
the symbol. It's 4 pi something.
Yeah. So that's E naught. So that is him telling you what is K. K, a constant, comes from 4 pi E naught. That for now you just treat it as memorization. So that's all he's telling you. What is small k? That guy, look. Okay, that's all. What the heck is that? We'll see later. But there is no fancy stuff going on here. It's just that simple. Okay. Okay. Now, same thing with the electric field, no? So this one, okay, ma? Right? That part okay, ma? Correct. This is what we just covered. What?
I cannot even recognize it as a thing.
Small k. Small k is there, right? Small k is there.
Ah, yeah.
Right. The Q1 is there, right? And over R square is there, right? Over R square. I purposely separate the 1 over R square, right? Right. To focus our attention to that, right? So it is done there. Correct. That part is done. If that part is done, that means
this one is the same.
Same thing, precisely. Same thing. And the guy below also the same, right? See,
I was staring at this part, and then I was like, huh?
Correct. But he's just exploring the K for you. That's all. I don't think it's a necessary detail like that. I don't think so. I think it's an unnecessary detail. But voila, you understand? You understand?
Yeah.
Right? Even this guy, you understand what? This guy is the relationship between, that's a F, that's a F, right? F on top. So E field is force over charge. You know that one. Just now we discussed about that one. Right? Field and force, the relationship is a charge. That's it, look. Correct? No surprises there. Am I making any sense?
Yeah.
All right. Same thing here. Okay, here below. The relationship between that is, oh goodness me, they don't use a very nice symbol. So the symbol they use for W is EP. Totally confusing to big E. It's very confusing when they put it that way. When they say EP, they don't mean E. They don't mean big E. They don't mean it's supposed to be. Why don't you just put?
EP kind of makes more sense than W though, because it's like electric potential.
As long as you don't get confused with big E, which means electric field. As long as you don't confuse that.
Yeah,
as long as you don't get confused with that. Because everything is new, then therefore everything becomes confusing. So trying to avoid that right now. Right? Trying to avoid that right now. So it is true that the work that we're talking about is more like potential energy. You will see later what it means. But my point is potential energy work is related to the potential V by a charge. You know that just now. We covered that just now. Right? Suffice to say, this whole summary, we cover everything just now, plus the graph.
Yeah.
Right? So there is nothing new anymore, and therefore we are ready to understand what they mean. We try to use them also. Okay?
Okay.
Right. Okay, so that is a good start. I really want a question. Okay, I want a question from your lecture note, right? Okay, let's go back to your lecture note. Let's go find some questions at the end, right? Right. By the way, I forgot to tell you the purpose of today's tuition. The purpose of today's tuition is to make you able to read this chapter. So that means your homework is very simple for Wednesday. Not so much on doing some question. If you want to, you can. But you read this chapter to start gaining an understanding of what the heck are these four brothers. Okay. So my purpose just now is to make sure that there's as little confusion as possible lah. That's my purpose lah.
Okay.
Yeah, right. So then when you start reading stuff, you can do so. Now, when I try to do a question with you, I'm also trying to reduce that confusion when you read yourself. So for example, page 53 lo. Okay. So I'm going to ask you to take a picture of page 53 and put it in the Jamboard page 8.
Okay.
Now, what will happen when you read your lecture note is that you will have question marks. That means I expect on Wednesday to have your lecture note dotted with question marks all around. Okay, I don't understand this part, I don't understand that part, I don't understand this part, I don't understand that part. Okay. That is the proof that you read lah. Oh, you know where you don't understand, kind of something like that. Okay, yeah. Right. So that will be your homework lah for Wednesday. Now, let's try to do this.
Okay.
Multiple charges, right? So he asked for potential. Don't know what that is. I don't know what that is. Okay. I haven't explained what that is. However, the formula is very simple. The formula which you have in your booklet, right, states that the potential kind of varies with the distance, right? So the potential is K, the constant, whichever charge causing the thing, and then 1 over R, correct? So currently, I'm not referring to any graph, I'm just referring to the formula, right? So the potential at P, whatever that means, is it caused by Q1 or Q2 or Q3 or what?
The sum.
Yeah, that's it. This is a slightly new concept lah. Yeah, obviously, if I have 3 charges around me, I will be affected by 3 of them. This is totally the same as field or force. What's the field at P? Well, the sum of the fields caused by the individual charges lah. That's all. This concept of summing up the effect doesn't just work for potential. So I'm saying it'll work for force, it'll work for field, it'll work for energy also. Just say, okay. Potential is just an example. Okay.
Yeah.
So potential due to Q1 is, would you please write that down in Jamboard also, okay? Potential due to Q1 at P is?
Potential due to Q1 at P is Q1.
But the Q must also be Q1. Good. And where's the K? You need the K, like, yeah? There's a K in front.
So in this case, there's no Q? No.
Yeah, there's always a K there, right? Okay. And then R2, yeah, there's a K there, right? Okay. And then plus. Okay, right, something like that. Okay. Now I'm gonna put one more extra point, and then I'm gonna ask you to put a question mark also, right? Now the question mark comes from the last sentence. Remember, blah, 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 blah. I think this qualifies for a question mark, don't you think? Try reading it.
The electric potential at any point outside the charge is exactly the same as if all the charge had been concentrated in the center.
What the heck does this mean, right?
Don't know.
Put a question mark.
Okay. So I put on the physical one.
You can put a physical mark. That means this demands your attention sooner or later, right? Sooner or later, right? So the question mark should be there with a pencil, right? Pencil, because one day you're going to erase them, right? Okay, something.
Oh.
Okay. I guess you can put it with a pen, but next time just put it in a pen. So I expect this kind of question mark dotted lah in your lecture note, not a big question mark, specific question marks. Okay, right? You can even go more specific, like what the heck is a charge sphere, right? what is what is he talking about? That's up to you. Okay. Now I'm going to add one more point. It may be a question mark for you. Ainesh, I can see you. Yeah, Ainesh.
Yeah.
Right, Ainesh, I can see you, and Kakak Brian, I can see you also. Right. Is it time, Kakak Brian?
Time. Oh yeah, we went through his homework already.
Right. Okay. This is now time to go through the next homework, right? As in read, right? Correct?
Yeah, I think so. Yeah.
Okay, so I'm gonna join you, both of you, in the breakout room, and then Daniel, for a while, give me 5 minutes. For a while, you're gonna read your lecture note from the start, right? Okay. In attempt to understand and to put question marks, lah. Yeah, the physical one using pencil. Okay.
Thank you. Wait, read
Right. The lecture note.
53
No,
onwards? Or
from the start. From the start.
from the start? Okay.
From the start. Okay. There's no rush. We just read slowly. Okay. Right. I'll see you in a while. I have to go to the breakout room for a bit.
Yeah.
Okay. Ainesh and Brian, do follow me.
Tomorrow math
Yes.
why you so stressed 一直 people 那么大力
Yeah, I'm still on the call. I'm still on the call. It's fine. Give me a sec, I'll mute.
Yan Keen, are you okay?
Yeah, I'm fine. Doing the financial one.
Sure. Right. Now, Daniel, how does it feel for you to, well, read the lecture note?
It feels like reading lecture notes.
I guess so. Any question marks so far?
Yeah. Okay.
Show me some of the question marks.
There's this concept.
Okay, let me see. Hence, for both electric and this object will move along a field line work with it. Okay, that is a very good question. Why do he even put it at that point? Yeah. Oh. Okay, this is gonna go back. Maybe this is gonna go back to our work, energy, and power chapter lah, probably lah. So I'm referring to that chapter, maybe in semester 2, maybe something like that, right? Okay, so I need you to put your two palms together in front of you and in front of the camera also, right? So I can see them good. Now, instead of just staying there, you're going to push your hands against each other, lah, right? Okay, you can feel the effort there and nothing is moving, right? Nothing is moving, correct? Okay, if you want to, your right hand can push your left hand, vice versa, but you're going to push at the same strength, and therefore it's going to wobble a little bit, and you're going to feel that you're spending a lot of energy, but other than that, nothing else is moving around. Okay? And yeah, so are you pushing because you don't feel like pushing? Okay. So you're pushing against each other, okay? Right? Okay, then you can relax now. Now my question is this: when you're pushing your hand against each other, are you working or not? Are you exerting work or energy lah, using your
You are exerting force, but work is not being done.
All right. How come you feel like you're working a lot? I mean, you're working out a sweat,
Because the forces are equal and in opposing directions, so the net force is 0.
Correct. The net force is 0. Correct.
Even though energy is being spent.
Energy is being spent. Obviously, we're getting hotter. Obviously, our chemical energy is running down, right? Chemical potential energy, but no work according to physics definition. You are not confused with that at all?
Not very. I couldn't get it.
All right. Okay. So imagine now, I am pushing the table against you and you are pushing the table against me. We're doing a tug of war, but pushing, okay? Clearly, you're doing your best effort to push at me, but I am so strong and so well built and so fit that I push you backward with the table. But you're still pushing back, right? Okay. You are clearly exerting your fullest, effort against me, but you're being pushed back. Are you working or not according to physics?
I would say yes.
Describe the work happening.
Direction.
There is movement, I suppose. There's direction, true, but
it's not in the same direction as the force.
Your force, you're trying to move forward and you cannot push backward, no, right? Something like that.
Yeah.
So think about it. That means I'm doing work according to physics.
Yeah.
I am doing positive work. You are doing negative work. You're being done work. You're being done work by me.
Okay.
Negative work means that. Okay, I'm being done work. Right? If you're stronger than me, then you're doing positive work and I am doing negative work. That's just what it means in physics. So negative work means basically you're being pushed by some other people or by some other thing. I guess that's the best way of thinking about it. And positive work means you're pushing against something. Right? Okay, so far so good? Now read the sentence. Along a field line means along a almost force, right? Along an almost force. Correct. When a movement happens along force, almost force, right? Almost force. Consider field as almost force. If a movement happens, then work will happen, whether positive or negative. Simple, right?
Yeah,
Right. That's the first
Yeah.
sentence lah.
the printer is
Okay.
on beside me.
I'm sorry, you saying?
The printer is on beside me. I'll mute for.
All
for
right.
now.
Sure.
You were saying? Sorry.
Right. Can you accept the first sentence?
The along a few line one.
Yeah.
Yes.
So let me reread for you. Along a field line means along the direction of force lah. Because field is almost force lah. Field is just force waiting to happen. Just pretend it's force for a while lah.
Okay.
Okay, can?
Okay.
So there will be work lah, positive or negative. Now, right angles. Right angles is his way of saying totally not in the direction of the force lah. Totally not.
Oh.
If it is slanted, at least there's some component of it in the direction, at least.
Oh, so you think
Right.
of the field lines as force lah?
Yeah, almost force. So force though, I mean, I'm going to shortcut that for a lot of time at the start lah, at the start. Until you finally understand why we ever need field and differentiate for force. I'll just pretend it's force what, it's force what.
Okay.
Okay, so the right angle one also clear that there is no component along that direction. So voila, zero lo. Zero
Okay.
work lah. And,
Zero. Can.
okay, therefore, that question seems legit and the answer seems to land lah. I would rather answer honest question mark like this, no?
Okay.
Right? So that means your job when I ask you to read is not to understand. It is to understand your question. And
Okay.
tell one whether you read or not. Can tell one. Very easy to tell one, right? If you don't read properly, it's not that you don't understand. No. It's that you don't have proper questions. Okay. This will always be a standard of doing things as long as we're trying to get ahead of the class. When trying to get ahead of the class, you have to read something that you have not done before. So you're going to generate questions. Did this make sense?
Yes.
Right. Now, obviously, I didn't ask you to read straight before. I tried you a little bit, help you with the essentials first. Then you start to be able to, recognize your question. Not everything is a blur.
Okay.
Okay. Would you continue generating questions for a while? Right?
Okay.
Okay. Right. So,
Is it our lesson over already or?
Lesson is over. Right. 1/3.
Yeah.
All right. Then you know your homework. Read everything.
And question mark.
Yeah, and question mark. And then that's how I think Wednesday we progress.
Okay.
Okay. All right. Okay. So what do you think about today? Just a rough impression.
Enjoyed it. I think I learned a bit.
Good. Let's
Is it
go with it
okay?
for a while.
Wednesday we do in the afternoon instead of at night.
I have some events going on here, so I'll answer using the WhatsApp if we can.
Okay.
Don't mind that.
Sure.
All right. You have your homework. I'll see you on Wednesday.
Yep.
All right. Bye-bye. So, Yankin, I do suggest that you're going to end very soon, yeah?
Yeah, I think I should.
Right.
Having trouble figuring this out, but I think sideline.
Kakak Brian, thank you for helping me. This 1.5 hour for today. So I'll be with Ainesh, right? I'll take over from here.
So tomorrow is there lessons or?
Tomorrow, actually tomorrow will probably be, I don't think the O-level students are going to have any problem. I don't think so.
Yeah, yeah.
Right. So let's meet up on Wednesday lah. So there's a slight shift lah. Slight shift in our schedule.
Wednesday, 8:30 or 9?
8:30 also first lah. Let's keep it at try. Right. Probably the same thing happening as today lah.
Oh, sure.
Okay. Right. I'll see you on Wednesday then.
Okay.
Okay. All right. Okay. So, Yankin, if you have a question, do ask lah. But if not, let's close the day lah. Wonderfully.
I think I might have one.
Let me talk with Ainesh for a while. Let me talk with him.
Yeah.
Answer that. So Ainesh, today we didn't get a chance to talk about the science lah, right?
Yeah.
Do you think the time is well spent?
Yeah. I cleared up a lot of my polynomials because it's something new.
The reason is very simple, right? For the 1 hour, because it's a depth from yesterday, man. You
Yeah.
were doing your homework and then you did discussion. That means the positive side is that you were doing your homework.
Yeah.
The bad way of going about it is that you don't do your homework, so you don't have to discuss very long, but that's bad lah.
Yeah.
That's bad lah. That's even less progress lah. Right?
Yeah.
So your science reading is not in vain, yeah. So it simply means when we have time, we're gonna accelerate lah, your science lah, your chemistry in this case, right? There's still chemistry, and then there's still the physics pressure one, which we can accelerate lah. Right?
Yeah.
Okay. But we don't have time to do it today because I think the time is well spent. Right. Now, are you ready for your homework tomorrow?
Yeah.
All right. If there is nothing else for today, I will see you tomorrow.
Okay.
There is no additional reading for now. If you have read your metal fully and your pressure fully, that's it. It's okay.
Okay.
Just do your homework.
Yeah. Okay.
All right. If it is okay for today, I'll see you tomorrow then.
Okay. Bye.
Bye-bye.
Have a good night.
You too. Okay. Yes, Yankin, I'm seeing this investing blah, blah, blah thingy. Right?
Yeah.
So if you could tell me your question.
My issue is this question, not with
Right.
the first part, but with the
Right.
occurs on the first and last day. So about this is my effort.
So have you checked the answer key that your part B is correct?
I should.
Yeah. So just make sure that first, and then because everything seems. Oh, wait a minute.
Yeah, part B is correct.
Right. How can C look at that? Look at C for a while. C is 50,100, right? Times something in the bracket, right? Something in the bracket, which is going to be which is going to make it very small. I agree, right? Bigger than 3,000. Could you let me see the question one more time?
Yeah, sure.
Is it the interest that we're talking about? Oh, I see. Right. Okay, the principle. I understand. Okay, good. So what is your question? Is it the first or the last day?
Yeah.
All right. So the first day of the month is equivalent to the last day of the previous month. You can call it equivalent conceptually. Right? Conceptually, they are not equal, obviously. For example, the investment happened in the first day, correct?
Yeah.
Not in the last day of the previous month. What happened in the last day of the previous month is the interest coming in. So the interest coming in on the 31st, and then the day after that, the 1st of April, let's say, then the 100 comes in.
Okay.
So I would think of it this way. I would think of it that if the last day of the month before is 2,900, that means the first day of the current month is 3,000, something like that, right? So if that's not confusing, so look at that. So
This is the
29.
Last day
Alright.
of
Can I confirm that that's the last day of the previous one? Can I confirm that?
Yeah, because I did this right.
All right, so that was talking about the last day, right? Not the first day, right? Okay, good. So that means if it is 2,988, obviously the first day of month 30 is 3,088 lah.
Plus 100
Plus 100. Then another interest come in on the last day, which makes it into 94 lah, from 88 to 94 lah, right? If that makes sense lah. If that makes sense.
Okay.
So I think you can already answer the question, right? The answer should be
first day of the 30th. First day of the
130. All right, correct. If that makes sense lah.
Yeah.
Right.
I think this is the most basic one I could find.
Oh, no. Although it feels basic, the details are important. I feel that your question reflects your attention to the detail. You don't pay attention to detail, no need to do this question one. No need. I feel that you're paying attention to the detail lah. This is not basic, man. This is not the easiest thing to read and do properly. No, it's not. That's why people fail. This question, this particular question. The details are very important. Okay, so I'm not saying that you will do it tomorrow successfully, but I'm praising your reading.
Okay.
Right. Anything else?
No, I think the rest is just everything else on me.
Tomorrow, when you are sitting and starting to do, I will also be sitting and start to do things, right?
Yeah.
Right.
I
discover. You're saying?
I know what I need to do first. Plan it, read it for good amount of time.
Good amount of time. Target to close properly.
Yeah.
No rushing is needed because you're maximizing you go for quality, right? Yeah. You'll have enough quantity, right? You have it.
You were saying?
As long as you focus on your quality instead of quantity, you will maximize your result.
Yeah.
Forget about your goal. This is the first time I'm saying it. Forget about your goal. Your goal is not a mark. Your goal is to maximize. Meaning you're going to minimize your mistake. That's what it means.
Right.
Right. That is all that is expected of you tomorrow. Okay. Believe it or not, you did well so far. Considering everything, you did well. So tomorrow, when you're doing and I'm doing, I discovered that during my O levels, I also did the O level AMAT, right? Because I've never done it before, right?
Yeah.
I discovered that I can concentrate and at the same time think about my student. You're my only A-level student this year, right? So it is easy for me to understand what you're going through, obviously. And therefore, for whatever it's worth, I am praying. Makes it very easy for me to pray for you. Inside the exam room. It's a total concentration. Right? Okay. If there is nothing else, then have a good rest.
All right. When should we next meet?
What do you mean?
When should we next meet? Because I have camp on Thursday.
Oh, no. This week we should probably still meet for camp and paper 2 probably just for morale support.
So that means
chemistry is going to be on Thursday, right? Thursday. So I suppose you can pop by on Wednesday if you want to. Right? And then pop by on Thursday. Just pop by, if there's nothing to do, then you just do your stuff, simple stuff. Right?
Okay.
In the end, it is morale support. Okay. Now, what do you need to do? What do you need to do after tomorrow's exam, right? You need to go back, you need to have lunch, you need to refresh yourself a little bit, right? And then you're going to recall and read everything that you have done for paper 2. No new papers. Right? No revisions from lecture note. You're going to read your paper first just to get back everything that you have left behind. Okay? Can you hear me? Can you hear me? Can you hear me?